Okay, so this is now my ready to plug in to the other equation to do substitution. Now listen, guys, look. A minute ago when we did problem number 1, we chose to isolate the x, right? So we subtracted 5y and we had this. So we took what's in this purple box and plugged it in for x in the other equation. Look what has changed. You have to pay attention. Y is now by itself. But Sally, let's stay off of our Apple Watch and pay attention. So I have y by itself, so I'm going to take what's in this box, go to the other equation. When I say the other one, I mean the one that I haven't done anything to yet. And I'm going to plug in for which letter, x or y. Am I going to put this in for the x or for the y? Does it matter, Alan? Can I just do whatever I want? Yeah. So you're saying I can plug this in for x if I want to? No. No. Cannot. Okay? This is a big deal. This is very, very important. You do all this work, you plug it in for x, everything's wrong. Okay? You have half a sheet of paper of wrong work. You guys have got to understand. Y equals whatever is in this box. I can't say this equals x. It doesn't. It equals y. So I have to put it in for y. This is going to go right in for y. Okay? Just like, look. This problem, what was in here equaled x. I'm not allowed to put this in for y. It doesn't equal y. It equals x. So I put all of that right there. It matters. It's a big deal. Okay? So I'm going to just start plugging in. 3x plus 2. Open up my parentheses and put everything in. Close my parentheses and then finish the problem. And now it's just solving an equation, going through all the steps that we just talked about. I see parentheses. I know I'm going to do the distributive property. So look, I'm underlining it. I'm just focusing right here. That's where I'm focusing. Okay? And I'm going to distribute positive 2 here, positive 2 here. So 2 times negative 6x is negative 12x. And 2 times negative 39, right there in your calculator, would be negative 78. Right? So I've done that part of the equation only. I'm going to bring down the negative 15, and I'm going to bring down the 3x. Now look, I did leave this positive out. Could you put a plus here? You could, but understand that 3x plus negative 12x is the same as 3x minus 12x. They mean the same thing. Fewer symbols is probably better. No, it is better, okay? So since this 12x already has a minus in front of it because of the distributive property, we already used that positive, right? It was like a positive 2, so we don't need to write it there. Okay, again, we have like terms on the same side, right? We don't do opposite. You don't subtract 3x from negative or add. You just read it left to right. 3x minus 12x. So in my calculator, I would type in 3 minus 12. And in my calculator, 3 minus 12 will be negative 9x. Bring everything else down. Now what, Sylvia? Add 78. So all that's left on the left-hand side is the negative 9x, and then 15 negative plus 78 is 63. Gabe, what's my last step? Divide by negative 9. Use your calculator if you need to. but x is negative 7. We just found half of our answer, but don't worry, we already did way more than half of the work. Okay? So remember, in your ordered pair, it's always x and y. In this example, our first solution is actually the x. Make sure you put it in the right place up here, okay? As a reminder, when we did number 1, the first work we did, we got y first. It just depends. It can be either one. Just follow your work. See what you're writing. Those of you that just write, don't write all the steps and leave off letters and stuff, this is going to be harder for you. If you're doing your work like me, you will see it very clearly. It says x equals negative 7. Okay, that means I put negative 7 in the x spot. Okay? Now I need y. Okay, you can plug negative 7 in 3 different places. You have choices. Plug it in here, plug it in here, plug it in here. They'll all give you the same answer, but one of those equations, 1, 2, or 3, one of those equations is so much easier than the other 2. Which one? 1, 2, or 3? 3. But you can choose 1 or 2 if you really want to. You're not wrong to do it. But again, why? Why would you want to give yourself extra work? All right? So, negative 6, and I'm putting this negative 7 in for x right here, right? So that's multiplication. And negative 6 times negative 7 is positive 42 minus 39. And when I put that in my calculator, I get y equals 3. It makes sense that my answer says y equals something because that's what the number I need, which is y. Okay? We just did 2 problems. In my handwriting, it takes up a whole sheet of paper. Look at all of that work. Look at all of the places there's a potential for missing a tiny little sign and the whole problem being wrong. I get that this is challenging, and I'm super appreciative, Caroline. I'm super appreciative that most of you are really paying attention, okay? I see you writing. Hopefully you're not just writing blindly. You're actually taking it in. That's going to be the difference between good test grades and not good test grades, okay? This is a lot. Okay, when you go to the homework, we still have 2 more to do, but they're not as long as this. When you go to the homework, make sure when you do your first one, like this was the first one we did, and I got negative 7, look up at the key and make sure that my key says x equals negative 7. If you got something different than me, don't keep going because it's wrong. There's only one answer. It's not like we can all get different answers, okay? So use your notes to follow the steps. We have tons of examples we've done together. All right, last 2 are our special cases where you get no solution or infinitely many solutions, okay? So these are a lot shorter. When we realize that we have one of these, we should get excited because the work is more than 50% less than the other problems. Let me show you. So we've actually done these, we did these a couple of days ago with substitution, with the easier substitution problems. But I just want to remind you with graphing, one solution, they crossed it in ordered pair. No solution meant they were parallel lines because they're never going to cross. And infinitely many solutions was where they cross everywhere. They're the same line. Well, we're not graphing, so we have to have another way of telling when it's one of those special ones. The special ones being no solution or infinitely many solutions. Okay. So let's just attack this problem like we attack the others. It says to solve using substitution. I need to pick a letter to isolate since there was none given to me. I see that this y is already by itself. That's the chosen one. So I'm going to isolate that y. Gabs, what would I do to isolate the y? How do I get that y by itself? It's okay. If you don't know, just say, I don't know. It's okay. Miley, can you help? Yeah. We've got to get y by itself. 3x has to go to the other side. It's positive. I'm going to put a negative. All right, so let's not get hung up on minus and negative or positive and plus. call it what you want. These are now opposites. Does that make sense, Gabs? Okay. By to the 3x on that side, but don't forget you got to do it over here. Okay? Technically, the order doesn't matter. Like I said before, I am going to put it in slope-intercept form just to get myself to always do that for graphing purposes. Just smart to always put the x first. Okay, I isolated for y. Y equals what's in this green box. I'm going to go to the equation that I haven't touched yet, which is the one that starts with the 6x, and I'm going to plug it in. Am I going to plug in for x, or am I going to plug in for y? So, guys, listen. Y equals this. What did I say? Y equals this. This is a y. You can't plug in what that y equals something into for x. It doesn't say x equals this. It says y equals this. Is there somebody in here that gets it? I know Sylvia gets it. Many of you get it. Is there something that I'm not saying that would help anybody? Is there some way others look at this to help them? Because every time I ask this, I get a bunch of you saying the wrong answer. Does it seem? I don't know. I'm perplexed. Why is this? I have to go over to the other equation, and I have to make a decision. Am I going to put this stuff in here or here? And there's only one right answer. This is not where you get to choose. Y equals this. I'm going to take that stuff in that box and plug it in for the letter it says that it is. You have to match the letters. I don't know how else to say it. I don't know. All right, so 6x plus 2. Take out y, plug in what y equals. Equals 10. And then for the 5 millionth time since the beginning of the year, solve the equation. Distribute. So I'm bringing down the 6x. 2 times negative 3x is negative 6x. 2 times negative 5 is negative 10. And then let's bring on that down. Okay, just like every other problem, combine like terms. On the same side in this case, yeah? So 6x minus 6x, what does that equal? 0x, meaning they cancel, right? 6x minus 6x. So when your x's or y's, whatever letter, when your variable goes away, you then look at what you have left. What do we have left? Negative 10 equals 10. Is that true? If I have $10 in my account and you have negative $10 in your account, do we have the same amount of money? No. These do not equal each other. So the minute our variables went away, we knew this was one of our special ones, either infinitely many or no solution. Now that we simplified it, what do we think? Infinitely many solutions or no solution? No solution. And you're done. You don't have to keep going. Okay, that's what I meant by we like it when our variables cancel because it's a lot less work. Last one that we're going to do together. You can probably guess what the answer is going to be. Okay? Directions tell us to solve this system using substitution. So what your brain tells you is substitution, I need a variable by itself. Did they give us one with a variable by itself? Yes, thank you very much. We haven't had one today, right? Sometimes we're given one of the equations solved for x or y already. Sometimes we're not. It's up to us to kind of know what to do. So since y is already by itself, I can just take what y equals and plug it into the other equation. I have a choice. I can plug this. I don't really have a choice, like a right choice, a wrong choice, but there are two letters in the other equation. I can put this in for x or y. Which one should I plug negative 3x plus 4 in? Should it go in for x or should it go in for y? Y. Yay. Because it says y equals that. So it has to go right here. If it said x equals, then I would plug it in here. You just read it, okay? So I have negative 6x minus 2, open my parentheses, plug in what y equals in place of the y, and then finish the rest of the equation. Distribute. Right. Negative 2 times negative 3x is positive 6x. Negative 2 times 4 is negative 8. So I distributed, bring everything else down. Don't forget there's a negative 6x in front. Well, there's no sign in front of this 6x because it was positive, right? We don't write a plus there, so we talked about this just a few minutes ago. Negative 2 times negative 3 is positive 6. So we don't have to put a plus there typically, but since we're bringing something down, we have to have something in between. Should I put a plus or a minus? A plus, because it's positive. If you put a minus in front of it, it makes it negative. We don't want it to be negative. It's positive. All right, combine like terms on the same side. Again, they cancel. It's coincidence, by the way, that it ended up being 6x and negative 6x. It could be any number, but they're opposites. That equals no x. Look at what you have left. Negative 8 equals negative 8. Is that a true statement or a false statement? True, of course. Negative 8 equals negative 8. That means infinitely many solutions. Okay? So you now know that when your x's or y's, when your variables go away, there's none left in the equation to solve for, it's going to be one of these two answers. Okay? Okay, so you have 3 problems to do. So I'm going to put up the 3 problems for you guys to do using substitution. I'm giving you the answers so you can check yourself as you go, but you still have to show the same work that we just did. Okay? I had a lot of questions on number 5 at the very beginning, so I am going to get you guys started on number 5. So I'm going to take this down, but I'm going to write it right here. So here's number 5, your first problem. You can keep it on the same sheet of paper. Continue on to the back if you need to, or staple another sheet to it. I don't care. Just you be organized and labeled so you know where your stuff is individually. But same piece of paper is fine. Okay, solve using substitution. I need to pick, none of them are by itself. I need to get one of them by itself. Clearly this first x is the easiest, so let's go with that. To get this x by itself, Sadie, what would I do to get x by itself? Let's Sadie do it. Subtract what? I want x to be by itself. So there's no 2x in the problem. Aristotle, help her out. What am I going to do to get x by itself? Subtract 2y. Do you see that, Sadie? Yeah. So x equals, the order you write this in makes no difference. Do what you please. Okay? Plug it in the other equation. This is the part some people were confused about, so I just want to talk about this real quick. I have to plug this in to the equation that I have left. And I'm plugging in for x, right? I'm putting all of this in right here. What does that negative mean on the outside? It's like a -1. If it helps you, you can put it there. You're not breaking any rules. So when you put that in there, it's like a -1 times all of that. Okay, and I'll stop there and let you guys work, but that's the question some people had in first period. So you'll distribute, combine like terms, and continue on just like the others. So if you see a negative in front of something, it's like a -1. So if you want to write it, there's no problem you doing that. That helps you see that. Okay? Use your notes, show your work. We have plenty of time to get 3 problems done, especially one of them is one of your special cases. We know that that's really shorter. Did you write all this stuff down? So look, so what would we have done next here? So you just combine them. You got that. Then what did I do? Added 68.
I guess not.
See them right there in the corner?
Thank you.
Amen.
I added 68. So what is the number? That's called plus y, that's called minus y, that's called divided by y, that's called minus y. With the opposite sign. Yep, we'll divide both sides by 12. And that would give you your y value. Then look at the notes to see what the next step would be. We got y is 2. And then plus, so, what did you, so that was good, right? Perfect. Y is 2, you put it there. Excellent. And the next step is to plug in 2. You want. Oh, is that the okay. Oh, I see. Okay. Sorry, I thought you were telling me. So let's simplify it. Look. What's 2 times 2? So it's x plus 4 equals 13. And then what's the base? So you doesn't make it even more sense. But a little step for you know how you found this y value of 2? Why didn't you cover one that already has that side? That would have been Now,